Okay, I think we should probably get going, and then as people add, they can kind of come in. So yeah, welcome everyone. This is our first webinar for our software, and yeah, thanks for taking the time out of your day. I know you guys are super busy. So I'm Steve Livingston. Excited to showcase our software today. We also have John Luca, and he's joining us as well, doing most of the presentation when we get into the software. So, oops, I did a double click. Yeah, so for today's agenda, what we'd like to do cover is kind of walk through the model itself, looking at the features. I think a lot of times people ask us, how does this software work? And so the intention today would be walking through the software, showing it its features, sort of step by step. We have a pre-built model already, and we'll use that, and we'll kind of add to the features and show you sort of how simple it is to create models. Um, the other thing that we like to do is show, we know some people on the call have more advanced or been using the software for a while. So we like to give you guys a peek into some of the more advanced capabilities. And then we'll end up with a QA question and answer at the very end. If you have any questions during the presentation, we can, raise your hand and we'll try to answer them or we can do everything at the end as well. So the genesis of the software came from one of my main issues as a site practitioner is I really wanted to clearly articulate my vision and tell my technical story. And sometimes I also just wanted to, really do like a quick model just to explain things to a client. And then other times it was more for, advanced models, mainly for, say, technical reports or risk assessments or RAPs. And I had one project where it was a litigation project and the clients were saying, hey, what about this view and what about that view? And I didn't have that view. I just had this kind of static 2D images that were created from me going back and forth with a designer. And I do have a modeling background. So the other side of the coin is on these advanced models, you end up with so much data requirements, interpolations, and then you have that model output, and then you work backwards to this visualization or CSM. So it was kind of stuck in between, and that's the genesis of it was trying to kind of fill that gap between a very sort of traditional model, 2D, and a more advanced model, which is numerical. So the criteria that was established in developing our CSM 3D Viz software were essentially four key attributes. We really had the site professional in mind. We wanted, go from a site concept, if you will, something fairly quick, and then advancing to data-driven construction or software that creates other files that you can also incorporate into your CSM. We wanted the software to be very high degree of visualization, 3 dimensions, lots of good rendering, meaning that systems work well together as well. We wanted it easy to use, rapid learning curve, just really to get you moving forward quickly and not have a lot of time spent on looking at tutorials and understanding the software. So that ease of use was one of our primary key attributes. And also the intent of this was designed for contaminated sites, mining sites, and risk assessors. So it was very, very specific to our industry and practice. Oops. Oh, this mouse is really, let's see. So here's kind of a schematic, and everyone loves diagrams. So here's our diagram for the day. So we have on this side, essentially bridging the gap between this low data requirement or this static CSM, this Photoshop, very sort of time consuming going back and forth, and then this high degree of mathematical modeling and software that's over here that needs a lot of data. the intent of our original version one was to create this gap, solve this gap that's right in between these two points. And the what we thought was our main objective was this really advanced 3D rendering so that you can spin it around and have a really good also a pre-built library. So you can really construct CSMs quite quickly. So that version one, which some of you have, we felt it solved that construction problem of 3 dimensions. Um, it was really to create these immersive models with advanced rendering, really targeting mining and contaminated sites. So since that version one came out, we've been working hard on version two. Oops. It's flipping. Excuse me for a second. So we've been working really hard on version two, which is understanding that people are also using other models. They need other information. They are seeking out advanced ways of showing their conceptual site models in 3D. So we've tackled this by incorporating the digital elevation models into our software. You can put LiDAR, photogrammetry. We really wanted links to GIS, QGIS, and math models. So now that if you're doing other software or have other outputs or inputs, you can bring those into the model. The things that we're going to be showing you at the end is now we're into data interpolations where we can show spatial mapping and volumes. Um, we know that risk assessors also are very important. And in terms of the work that we do. So we've created, a really robust library of uh, um, receptors that can be brought into the model, like fish and workers, etc. And the really cool thing about the software is there's links to third-party 3D assets, so you can bring in basically whatever you have. If you had a whole library of biological functions or trees, that can come in and it's pretty robust that you can really start integrating all the other different components into your CSM. The future is pretty interesting for us too. The software is built on a gaming software, Unity 3D. So that's why, again, going back to the special features of high rendering, it also, in the future, we're looking at animation and some really cool features that are into our future, um, and taking advantage of all the sort of the gaming software aspects and bringing that to life in our CSMs. So this is just a simple kind of before and after, if you will. So the left-hand side is, some of the models I was creating to describe um, some of my technical evaluations of sites, whether it be, contamination or DNF or such. And the one on the right is something I created for a client. They were simply trying to showcase what a PRB would look like in terms of um, a plume remedy. So I created this model. It's very conceptual. It was for understanding, kind of plume geometries, and then it would go through a PRB, and it'd show that kind of green on the other side. So it was very successful for them to show a client of, hey, this is what we do in order for a remedy for your groundwater plume. That model on the right, which is fully 3D, that took me about 5 or 6 hours to create. And again, that was one of those models that I created to um, for them to showcase what they would be doing in terms of a proposed solution. So I think right now I will pass it over to Gianluca, and we're going to be running through some of the software right now. And really, the intent of this is to show you how you can build a model, kind of its functions, kind of work through the nuts and bolts of the model, and then we'll get into some of the special features, some of the special things that we're doing, and then we'll end up with a Q&A at the very end. So John,
Yeah,
I'm going to stop control on my side and then I'll bring it over to
otherwise,
you, okay?
right. So, hello everyone, and thank you for joining us. My name is John Lucas, as Steve anticipated. Let me just stop sharing my screen. Let me start sharing it again. So, thank you, Steve, for an introduction. And I will just get things started because I want to show you guys how easy it is to CSM 3D Viz to use, um, how like this software, like when compared to other pieces of software, we can get things started with little to no data. So while for some software, even to get things even started, you need a lot of data, and sometimes that data is not yet available. But with CSM 3D, we're kind of trying to bridge that gap. But let's get things started. So this, I'm going to start by describing the user interface. So this is the user interface in CSM 3D. At the very top, we have the very basic functions, new project, open project, save, about, and manual. And then to the left of the panel, we have some of the functions that come within CSM 3D. We have the position asset, the rotate asset, and scale asset. So these three functions are the main functions with which we'll be able to move, rotate, and scale our assets in space. For instance, let's just add a random piece of geology. You can see how, like, we select move asset and we can move it along each separate axis or a combination of the two axes like that. Then, of course, we can rotate it. We can rotate any asset, and we can also scale them anisotropically like that, or isotropically like this. Now we have take screenshot function, add sitemap. So the sitemap you see over here was imported simply by using this function, and the map was simply a PNG. And it can be a PNG, a JPEG, or a JPG, or even a TIFF2, if I'm not mistaken. Then, of course, we have the delete object and add image. So we have a change topography, and this is the tool with which we'll be able to change the topography of a layer, but I'll show that later on during the presentation. Then we have add image. So this will add reference figures to each layer. So it's a layer-based referencing system. So if we click on the map, we can add a reference image to the map. If we click on the sand, we can add a reference image to the sand. Well, we have log object, pen tool, setting. So we have background color. So let's say, for instance, that the background doesn't do justice to the model you're currently visualizing. You can just go and change colors as you please. And then light intensity, which changes, of course, the light intensity and the lighting conditions across the conceptual side model. And then we'll have change opacity, with which we can change transparencies across the model. We'll get there also in a second. Then if we move to the right, we have two panels. We have the hierarchy panel, and then we have the asset library panel. Hierarchy panel kind of acts like active layers. And the very top here is we see all the building contaminants topology functions. This is actually filtering. These are all filters. So if we click on geology, only geology layers will appear here. Or if we click on buildings, only buildings will appear. And to get rid of them, you just re-click whatever you click last. Then we have the actual active layers. We have the plane, for instance, and everything else. And whenever you select one of the layers, it'll appear highlighted in green by a green box in the right panel, and also it'll appear within a green outline in the main interface. And of course, we can even use if you click on the eye function, we can show or hide the layer that we want to show or hide. Then we have the asset library, and here we have all the pre-built 3D assets that come within CSM 3D. We have buildings, contaminants, geology, landscape, etc. Then we also have three extra functions that I'll talk about more in detail later. We have import terrain, with which you can import digital elevation models and geological elevation models, which is, long story short, geological elevation models are top of the bedrock. Um, And also, if you don't have DEMs, you can just go and use open source software like like the Canadian DEM repository or NASA's repository. Then we have import CSV, and this is the option that will give us, this is the function that will give us, that'll let us interpolate plumes directly in CSM 3D vis, so long they are in an XYZC format. Now we have the import GLTF function, and this helps us with importing all the 3D assets that are not included in CSM 3D. So right now, I'll just go ahead and with creating the model, I would start by adding the structure. So I'll just add a tank, and we can see how basically draggy and drop it is. You can drag item, you can drop them in, you can move them around, you can rotate them, and scale them either manually, like I showed you before, isotropically or anisotropically, or using the manual scaling function. Right now, I want to scale this to 30% of its original size. Let's put it there. Actually, maybe let's make it a bit bigger. And then we can add as many things as we want. We can go in and add an industrial shed, for instance. We can go in, move it around, rotate it, and of course we can scale it. So let's pretend, for instance, that from this tank there is a leak of a contaminant. We can just go in and add a soil contamination. Let's add a bit of an anisotropic scaling, and let's rotate a bit like that. So there's this contaminant, and let's pretend that people went in actually and drilled some boreholes to monitor how this would spread in the underground. So we would go and drill a borehole over here. Then, so red would mean that the contamination levels are high, so the soil has been contaminated and likely, for instance, groundwater. But then the further away we get, the less contaminated it gets, until it gets completely non-contaminated over here, or even on the other side over here. So now we can go in and add a conceptual plume. We can go in contaminants and add a full red. So of course we can move it around. Let's rotate it a bit to match the boreholes. Let's scale it back. Yeah, let's flatten it, and let's flatten it. And then we can move it underground, just like that. And of course, now the problem is we see the outline of the plume. However, we don't see the plume from the side. So this is where the transparency option comes into aid. So we can go and change the transparency, just like that. And of course, the transparency is layer-based. It's not universal, as you can see. And the same thing is for the map view. So we would like to give a look at what the plume looks like from top. So we just select the plane option, and we reduce opacity. So we increase transparency.
And John, you could turn that off too if you show the turning that layer off.
Yes, of course we
John.
can turn it off like that, or we can just to have a reference, we can turn it on and increase transparency. But of course, we have complete freedom to turn it off, to turn it on, to increase transparency, to decrease transparency, and so on. So this is why I think this software is so powerful. So we already already have a story that is very clear to whoever is looking at this conceptual site model. And again, we created this pretty much with no data. So this is all very conceptual. Well, let's say, for instance, that we want to make an extra step and create a plume based on actual data. We can use the import CSV function. So this function works if first of all, if this comma separated values, so CSV file is formatted in an XYZC format, and if it's in a regular grid. If it's not in a regular grid, then I'll talk about it later. But for now, let's just click and import this plume. So let's give it a second to compute. So now we have an interpolated plume just like that. And we already getting more data driven. And of course, we just like everything else, we can go and scale it and rotate it and place it wherever we like, just like it was in a drag and drop scenario.
This,
So just like
this
that, yeah,
Yeah, no, I was just going to say, John, look, yeah, this is from a 3D analytical solution, and it's really easy. Just it's an XYZ set Z with depth, and we're able to bring that right in. This is a regular grid model, and yeah, so it's going from that first thing where you don't have any data, you just have some monitoring wells. You're trying to show, basically its general morphology of your plume, and this one is getting into more advanced, where you're actually looking at, an analytical solution for your plume too, which gives obviously a higher degree of interpolation, right?
yeah, yes, yeah. And then in terms of other functionalities, like before, I mentioned the topography tool. And if we click this, lets us modify the shape of um, of geological assets. For instance, we have two tool types, valley and hill. And then the amount we will set to 0.5, and then we'll set radius to, I don't know, 1. We just go in and deform the voxel, the geological asset that we imported. And also, what I really like is how well this renders through other layers. Just like that, the top layer adapted to the shape of the layer below it. Um, and of course, we can add also receptors. We can go in our asset library. So right now there is a deer over here and a couple of workers. If we want, we can add, well, there's a falcon over here. And if we want, we can add anything that let's add in another deer, for instance. Let's scale it a bit. So, and this is all part of the pre-built libraries within CSM 3D. But if you want to import, if for instance you're compiling a library that is external to CSM 3D, you can just go and use the import GLTF library. Let's give it a second to load all the assets. Like in this case, I've got a precompiled library of receptors and of machineries that we'll see in a second. There it is.
And,
So we can just
and this
go and
is
add a realistic deer.
Yeah. I was just going to say that, a lot of these 3D assets are very readily available for everyone just to download, and
Yes.
you can, like what John Luke is describing is just his own library of different 3D assets that we just basically pulled off other libraries. I've talked to others that maybe on this call that have some advanced software dealing with, say biology with different trees and things like that. The GLTF is a very kind of common function of being able to take a particular asset, move it into a GLTF file format, and then bring that right in. So it's highly functional to bring other assets into the software.
Yeah. Yeah. And there's a bunch of websites that offer the possibility of downloading GLTFs as they are, and they're free to use. And this is where I've gotten my models from. So again, I'm just importing a bear, or we can import machinery if we have a machinery library.
I think my favorite is your flapping bird, Gianluca.
Yes,
Yeah,
yeah.
I
We
don't.
can we also have animated asset that we can import, as you see. We can scale it to, I don't know, half its current size, just like that, and we can move it around like that.
You've got moving fish and flapping birds. It's pretty cool when that all comes
Yeah.
together. Yeah.
Yeah, yes. Yeah, it almost comes to life. It all comes to life. But anyway, so this is kind of the end of our um, basic like normal functions for CSM 3D. More a bit of the basic stuff. Let's build a model together, a simple model together. So as you see, we went from almost completely non-data driven to semi-data driven. So let me just put on the presentation again. So this is the way that we're seeing the let me reshare my screen. So this is the way we're envisioning the conceptual site models in the future. Very interactive, very easy to use. Very interactive and very easy to use with a non-steep learning curve, as I hope you appreciate it. Um, and so we were looking at integrating our models further with new functions, like for instance the possibility of importing CPT, LRF, and all in situ testing that, or XRF. For instance, we created a plume solely based on XRF data from in-field tests. So, and then digital vision modeling too. 3D modeling from numerical models, analytical models, and 3D data interpolation, which I'll tackle later during our presentation. 3D geophysical surveys, seismics. We were able to import seismics in CSM 3D as planes and position them in their, in where they're actually supposed to be. 3D geological models. We've had instances where we worked with CAD models, geological models made in CAD.
Yeah.
We worked with those, and we imported them successfully within the CSM 3D environment. Even DWGs, DXFs, OBJs, anything that all the major industry established formats, we managed to work pretty much no problem. But I'll
We
get there in a second.
we had some really complicated leapfrog stuff come to us in geological models that we had to transform into a hydrogeological kind of framework, and it yeah, it worked really well. So it seems to be well suited for bringing in um, all the other assets from analytical numerical models or complex
Yeah,
geological
it's
models.
yeah,
So
it's CSM 3D is very 3D based. It's very open to working with other pieces of software, so long they're in the right format. But again, I'll get there in a second. Then photogrammetry and LiDAR too. We one of the things I pretty much worked with photogrammetry ever since they started making an appearance in the geology sector, probably around 2016. I just had started my undergrad back then. I always worked with photogrammetry and LiDAR. Well, LiDAR a little bit later, but I always worked with like semi 3D surfaces. But one thing that I hated was that I couldn't put, so, I had this very good looking 3D model, but then I wasn't able to put that 3D model into a geological context or environmental context, whatever it is. I'll get there in a second with another model that I'll show you. Then also, of course, I showed you that we're also very open with work, and CSM 3D is very open to working with different assets coming, third-party assets coming from different websites or softwares. So I introduced the digital elevation models. Let me just share an example of that. Let me stop sharing and let me start sharing again. So this is an example of a model that comes in an example of model that is so on top of this we have a digital elevation model that you can see. So it's a fairly high resolution one. And you can see all the trees and all the surface features like this canyon looking feature. And then notice how it's wrapped in a texture. So CSM has the ability of getting a TIFF file that usually comes like in grayscale. When you have a TIFF file imported in a GIS software, it usually uses a grayscale, but it takes that TIFF file. If you have a texture file, takes this texture file and wraps it around the DM, leading to this result. You can see how this alone is very visual, but then of course we can go and change transparency, and then we can visualize a photogrammetric model. So this is a photogrammetric model of a tunnel, and see how it is within its geological environment and its geological setting and environmental setting. And then, of course, we can zoom in, can zoom right in the photogrammetric model and roam around by zooming in a bit. And then, yeah, this is why I like this so much, because it's so cool, it's so powerful, and now finally there is an easy way to take the photogrammetry, plop it into its geological environment with a DM on top. It all looks great. It it it's, and again, it's very visual and it's easy to understand even for people that don't necessarily are not necessarily familiar with the subject that is being discussed. Then
We're
also,
starting.
I just, sorry,
Yeah,
yeah,
so I was just gonna say, John, like we're starting to see much more kind of interest in using photogrammetry in
yeah,
our some of the mine sites and some of the more complex sites where some of these drone systems are really powerful now. They can have different sensors and this is bringing what they consider kind of what we consider kind of 2D or um, quasi 3D. And now with draking it into our model, then we're kind of fully
yeah,
3D.
fully 3D, yeah,
Yeah.
yes. And of course, we can still go further. We have, um, so this is a digital elevation model of a site we work with. And I anticipated to you geological elevation models, which are top of the bedrocks. So the one you see at the bottom here is a geological elevation model. So this is the top of the bedrock that is of interest for this client. And then the powerful thing is that we can see the bedrock in relation in relation to the surface geology.
That was
And then, yeah.
sorry to interrupt, John. That was I was just going to say it was a fairly large digital elevation model, and we're totally good with that.
Yeah, I
The
think 6
bottom,
or 7 kilometers by 3 or 4.
yeah. So it was
Yeah,
it was pretty robust and able to bring that in. The geological surface there was also created from I think over 600 data points to create that surface. So
hmm,
again, a lot of this information is coming in that we can highly visualize not only the digital elevation, but also, the top of bedrock. And then we fill that gap in with our overburden um, data interpretations.
yeah,
Yeah.
yeah. And yeah, usually you would see a digital elevation model or a geological elevation model, so top of the bedrock in 2D in a map. But here you just take the TIFF and this makes it directly in 3D. And then I also anticipated interpolating CSVs. And let me stop sharing. Let me go back to our PowerPoint presentation. So we wanted to take the chance to kind of announce a new piece of software that we're working on, which is called CSM 3D File Converter. And this will, through this converter, we'll be able to pretty much take any of the formats that are currently established in the industry, like OBJs, DXF, DWGs, shapefiles, and bring them into CSM 3D. So from this flowchart, you can see that currently GLTFs are natively supported by CSM 3D. Just like CSVs, so long they're in a regular grid and formatted in an X, Y, Z, and C, where X and Y are latitude and longitude. And then Z is the depth, and C is concentration of contaminants. And if they're in a regular grid, they can be handled no problem, as you can see, as you saw by CSM 3D. And also PNGs, JPGs, JPEGs, TIFFs also can be handled no problem. But then we stumbled on a whole bunch of new formats that we were working with, like OBJs, like DXF. OBJs like standard 3D format in the industry. DXF and DWGs, so CAD files, shape files, GIS files, CSVs. So if you want to interpolate a plume, that from starting from a sparse data set or a non-regular grid, you can use CSM 3D file converter, and it spits out a GLTF of what the plume looks like. And on top of that, we also are able to compute volumes of a material based on isosurface, but I'll get that in a second too. So all of these formats go in there's going to be an interface. Go into CSM 3D file converter, CSM 3D FC, and then you click run essentially, and then it spits out a GLTF that you can import in in CSM 3D Viz. So we're getting even more and more open to working with different formats coming from a bunch of different software, CAD, GIS, Esri, all the major ones in an industry.
Yeah,
So yeah,
yeah. I was just going to say, John, like we're moving into sort of the math model domain, if you will. So, for example, if you had a file that you're trying to look at, your plume geometry, and you had some really good information, some decent spacing of your monitoring wells. You can create basically a CSV file, which is a fancy way of saying an Excel file with this data, and then with that you could bring that file format in through this converter, and it will basically create a plume for you, a 3D
yeah,
plume for you. That now you bring that plume right into your model, and it's showing all the other features that you had before with the digital elevation, the site conditions, site maps, all that stuff. And now you've just created your own plume. You don't need to go to a different software platform. You can do it all natively in our software.
yeah, yes. And just FYI kind of thing. So CSM 3D Viz file converter will be kind of a sidecar app to CSM 3D Viz, and will be included in the subscription, and will come at no extra cost. So speaking about plumes, let me stop sharing again. I apologize for the jumping around. Let's go back to CSM 3D. And this is the plume that we create. We interpolated based on a very sparse grid. The way this plume was generated, so here we had a bunch of plumes that were very sparse, and here, as you can see, we pretty much had no data, and then some more data here, and some more data down here, low concentration values. So what we want to do is being able to put synthetic points, which basically are pseudo boreholes, manually. So you can go and place manually synthetic boreholes. Then those synthetic boreholes are assigned a concentration value based on the percentile distance from the closest boreholes. Then after that, we perform the interpolation, and this is what happens. And from this, so from CSM 3D Viz, this is a direct output from CSM 3D FC, and also the direct output is volumes that are stored in a separate CSV and are isosurface based, meaning that volumes of this isosurface is one volume, then we have another volume, a different volume in a new row with the volume of this isosurface and then of this isosurface and so on. And
So
that
you
is
could,
all with one click. You click run, it outputs this, and it outputs volumes. And if you want, you can include synthetic boreholes. Sorry, Steve.
yeah, no, I was just going to say this is a very heavy, rich XRF data set of soil
Yeah.
concentrations of copper with depth, and it's yeah, it was a ton of work. Um, on another figure, you can, maybe not on this one, but you'd be able to see all the boreholes that were used in order to interpolate this. We
Yes.
get thresholds, so as John Lucas said, we can get different concentrations, different concentration profiles, and then from there, isosurfaces, we can get volumes. So this is XRF. It could be LRF. It could be any other type. It could be a numerical groundwater plume output as well. So it doesn't really matter what the model where this data is coming from. but it's pretty robust that it's able now, instead of going external to other software platforms, we can do it all within this platform now. So
Yeah.
I don't want to name the different types of software, but you probably use them in order to interpolate. So and we did check, just so you guys know, we did a lot of QA on this, and we checked it with some of the other, industry standard software, if you will, for making 3D stuff, and it's pretty much bang on, like everything else. John Lucas talking about synthetic boreholes, those are really, basically control points so that your interpolation doesn't kind of go to infinity. So it's all about, like everything else, like preparing the data set, preparing that you've got it, and then, just with a click, you've got something. So we're pretty jazzed about this because this is really our next generation where we're integrating data that you guys are collecting and have, and within one platform you can create this, and then you basically bring this the shape into your conceptual model for the polish.
Yeah, yeah. And of course, within CSM 3D FC, you'll be able, so there's going to be an interface, and based on whatever kind of conversion you're choosing, there's going to be parameters. So this comes with parameters that will have, so you'll have to do some parameterization based on the way you want to see the plume, but it all comes within within one interface. There's going to be documentation if you need it. And again, once you get it to run, you once you're ready, you click run, and it spits out volumes, it spits out interpolated surfaces, or it converts OBJs to GLTFs, DXF to GLTFs. So we're again still part of moving toward more data driven, and being open to different software. So let me go once again back to my presentation. Um, so I really hope you appreciated how easy CSM 3D is to use, uh, how how like non how like easy it is to learn also. You can just go in, drag and drop, import it from anywhere. Like you have something in a shapefile, you can convert a shapefile and bring it in. You have underground tunneling in a DXF or DWG format, you can bring it in. And so it saves a lot of time and a lot of resources. That's what I'm getting at. So, when you have to build a 2D conceptual site model, you need to go back to, there's usually back and forth between engineers, geologists, and designers, because designers might not be, maybe they're doing something wrong, or there's something they can do. So we're trying to reduce, that exchange of information. So like a conceptual site modeler can go and make the model as quickly as possible. Again, as I hope you appreciated, it's very compatible with Esri and any GIS software, any CAD software, GLTFs, DWGs, DXFs, again, OBJs we can work with. And you can create very visual models. And in a world where conceptual site models are becoming increasingly necessary, even for the preliminary phases of a project. When you have to delineate a project that you got to submit to somebody, like a proposal, you most times you need, at least in our experience, you need a conceptual site model. And again, one last note. Again, CSM 3D FC is still not released, but it's going to be released soon, and it's still going to be part of the usual CSM 3D subscription. And there's an early bird discount on our subscription. Uh, Prices will go up eventually, so I would encourage you to take advantage of that. But if you want to try the software, and if you don't feel comfortable, buying the software yet, you can just go and download our free trial. It's completely free. You don't need a credit card. You can just go enter your email and download the software. That's it. No credit card, no nothing. So yeah, I think that's it for me. And
Yeah.
of course, we're all open for questions.
Yeah. I think really our take home is, we think this is software kind of changes the way people can make 3D CSMs, and it brings it back to the site professional to create those. And you don't need to be, a super seasoned person. It could be, a junior all the way through, and you can become that kind of that CSM expert, developing really, really awesome three-dimensional uh, CSMs. As John Lucas said, it's a subscription based. So, uh, but it's also concurrent. It's kind of like a book. So, a lot of people can download the executable file, and then, if you had one or two licenses, it basically just checks how many licenses you have, and then you can just kind of keep sharing it. The other way is it is kind of locked to your computer, and then it's only basically only one person can use it. But we decided to really kind of open it up so it's concurrent. So I think that's kind of, I'm sorry, we kind of packed a lot in to
Yeah,
this whole thing. There's a lot of jargon, there's a lot of stuff that we just
I
kind of
apologize
said,
for
and
that.
and we're I guess you can see we're pretty excited about what's created here, and we think it's a really good opportunity for people to develop some really cool stuff. So we wanted to open it up. If there's any questions, we also want to say we're fully supported here. We're here to make this really successful for you guys. If you have any questions on the trial, or if you have the software and you want to explore things, we are looking for those partners to create really interesting and take this to the next level as well. So if there's any questions, we'd love to discuss it. There's also, more information on our YouTube channel to look at different builds and stuff that we've gone through quickly here. But love to have any questions at this point. Blake,
Sure.
yeah.
Hello.
Hi, Blake. How
Hi,
are you?
Blake. Nice meeting you.
Yeah, thank you very much. That was a great presentation and yeah, really exciting product that has certainly piqued my interest. So I have a few questions, but I'll maybe just do one at a time. And the first one is just in terms of file sharing. So, you create a three-dimension 3D model and you'd like to share the file with maybe an external user. Is that done, like a web-based viewer type of a format, or is it like you have to send the files to someone and would they need to have the program installed in their computer?
Yeah, we're actually, it's a really good question. So we are getting a viewer version of this software. So there's going to be three different types. There's one which is sort of the trial version. So you can download it for 30 days and you can have a trial. And it's fully functional. So if you say if you had a client and you wanted to share a fully functional software package, it's the JSON, it creates a JSON file with a data. So it's actually really small. If you had a monster DM, then you might have to do something different than email. But they're generally a small file, a small JSON, and you can and we do that all ourselves. Is what we have a directory. We just share our files. We share our builds. It's pretty seamless. And then um, if they had the trial version, then it's fully functional. But we are getting a viewer version, and that's going to be probably in a couple weeks from now. Meaning you just send that file to whoever, and they can view the whole thing. It's not going to be They're not going to have a lot of functionality, but it's
Yep.
a viewer version. Yeah,
Right.
Viewer
Okay, so the viewer
version.
version is like is coming at some point down the road.
yeah, yeah.
Couple
And
weeks.
our, and our workaround right now is people can just download the trial version and just use that
Right.
for a while. Yeah,
Yep. Okay.
yeah.
Great. I do have a couple of other questions, but I'll maybe just park them until give other people a chance.
Well, like you're on a roll. I think you can
Yeah.
go.
Sure. Yeah, so just another question around just like kind of a help desk type of service or something comparable to that. So one of the things that I could see myself struggling with is just like, okay, a lot of this seems very intuitive, and then there are some other functions that I probably would need help with, or I've screwed this up. Can you help me fix it? Would you have that ability to provide ongoing technical support for users like me?
Yeah, yeah,
Yeah, of
100%.
course. Yeah.
Yeah,
And
yeah,
on top of our help, there's also YouTube channels that you can consult. We're coming up with a tutorial series. There's a manual. And of course, if it's anything outside those, of course, just reach out. Yeah, we're
yeah.
very open, yeah, to people reaching out.
Yeah, if you guys wanted like an in-house training, you know,
Mhm.
Yeah.
training program for an hour or two, and it would be free of charge. We just walk you through it as a group. Yeah.
Yeah.
But it's a really good point. Like we are looking for the partners who are, trying to do, innovative stuff with the software. So if you guys are stuck on something, or maybe we've done it and we've figured it out, we're totally open to scheduling a meeting, walking through your issues and solving it
Yeah.
100%. Yeah.
Yes.
Cool. And I guess, yeah, just the last question for me then would be clarification on the subscription. So you'd mentioned that at one point it was uh, device specific, but there are options to, or maybe if I heard that correctly, there are now options to have a subscription that would work kind of on a global scale, global sense within a company or like
Yeah.
within multiple users.
Yeah, that's right. We initially had this as a perpetual license. That's what some people bought initially, and that basically fixes it on a computer. Those
Hmm.
people who originally bought that software, we've said, hey, download this new software. It's concurrent, and there's no charge, right, for any of this. So concurrent means that if you bought a copy of it, and Blake, say you were working on the software, and then you're done with it, maybe your partner next door has the executable file, you basically get out of the software, they load it up, basically there's now a key check on them, and now they can run it. So it's basically there's a verification key that goes back and forth, and
Hmm.
that's all it is. So if you had two licenses and the third person tried to get on, they would get a notice that, oh, all the licenses are taken.
Right.
So it's a lot cleaner. It's almost like a book. I say, like you've done reading it, you give it to someone else, they can read it, but it's still within your domain. So you can have, all your desktops could have an executable file there. You just need to be able to, enact that executable file with that verification key, and then
Hmm.
that's good. Yeah,
Okay.
yeah,
Awesome. Thanks very much.
yeah,
No problem.
yeah. Like I guess personally, I was always frustrated when I would buy software and someone else would want to use it for a while, and it would be locked on my laptop, right? And that's super frustrating. So yeah, concurrent gets around that. Yeah,
Yeah.
Yeah. No,
yeah,
I can see that theme throughout, like the whole, you've lived through kind of finding workarounds and all these different frustrations that you have, like trying to build these models, and I can see that you've built solutions to move them out of the way,
right.
and to
Yeah,
make it more seamless and try to solve all those little problems that we all have when we've been working with other types of software. So that's
yeah,
cool.
yeah, yeah. That's great. No, it's really designed. It's designed for our this community that we're talking to right now, right? So yeah, thank you. That's awesome questions. Is there any other questions about functionality or such? Um, if there's anything that you guys think about afterwards, just shoot us an email, and we'd love to talk to you. And if you have any suggestions, if you're a user right now, and we've really picked up on some of the feedback that we received. One of them was for the red, yellow, and black and green monitoring wells. Just to show visually, really, really quickly what wells are impacted or green, non-impacted. So we're definitely open for that communication and that collaboration, and it's certainly well welcome because we're trying to build this tool out for like I said, this community. So really appreciate it. So yeah, give us if you have any questions, please reach out to us. And again, it's really appreciate your time. I know everyone's really really busy, and yeah, and thank you for your time. So we can conclude now. We'll probably hang on until 3 if there's any other questions. But yeah, thanks again for your time. Really appreciate it.
Thank you, everybody, for your time, and take care.
Thank you. Bye.
Bye bye.